Write a Python program to find whether a given number accepted from the user is even or odd. Print out an appropriate message to the user. So to be able to get a message from user, we use input function. So to be able to estimate if a number is odd or even, I check the remainder after dividing it by 2. Remainder is 1, then I know that the number is odd. For question 2, write a Python program to count the number 4 in a given list. This is my list, which is called nums, and I'm counting the number whenever I find a 4 in a list. For a num or for I in nums, right now I is going to get every value iteratively in this list. So whenever I is equal to 4, I'm going to add 1 to the count, and at the end I will see how many times 4 was in that list. Question 3. Write a Python program to print even numbers smaller than 401 from a given number list in the same order and stop the printing if the summation of these even numbers exceeds 1000. So this is already given. If the sum exceeds 1000, that's why first I'm defining a sum. If remainder of this value in this list is equal to 1, or if it's greater than 401, I'm not going to print this number. I'm just printing the numbers which is less than 401 and also even. So in this condition, continue command gives me the next value in the list. Whenever the code reads continue, it's not going to see the rest of the code. Whenever code sees the break command, the previous loop is going to stop. For is a loop here, so for loop is going to stop functioning. Then I would like to print the number, and I would like to update summation of these numbers, and if this summation exceeds 1000, I would like to print another statement, and then I will stop the function. In part B, we would like to print if all even numbers less than 401 are printed. We just add an if condition which says if index of x is equal to the index of the last item in this list, then we would like to print this statement. It means that this if statement was never valid, and we have never read that break command. Compute the greatest common divisor of two positive integers. So since we're going to find the greatest one, it makes sense. It's logical to start from the largest candidate. This is the upper bound, this is the lower bound, this is the increments we're going to have in this here. Since it has a negative number, this is a decrement. So k is going to take values from minimum of x and y, and it's going to stop whenever k is equal to 0. We check the remainder. If remainder is 0 and the remainder for y is also 0, then it means that k can divide both of them. We'll stop this for loop. It means that k is the greatest common divisor. We are trying to create a Fibonacci sequence, but we would like to find the sum of the even valued terms whose values do not exceed 4 million. First of all, I am creating an array here. Right now, sum of the even numbers is 0. So Fibonacci numbers, the next number is created by adding previous two numbers. So for me, the next number is the last element and the second last element. As long as this new number is less than 4 million, I'm going to keep adding this new number at the end of this Fibonacci function. If this Fibonacci number is odd, I'm going to go to the next Fibonacci number. If this number is even, I'm going to add this number to the sum of even numbers. The last element in this list right now is the new number because I have already added new number in my list. Prime factors means that first we will find the factors and we will find the largest factor, which is a prime number. We are looking for factors which is different than itself. This brings me to the logic of dividing the number by 2. If it's an even number, that's the largest divisor. If it's an odd number, then we will start looking at integer part of half of this number. So again, since we are looking for largest prime, I want to write this code as efficient as possible. I start with a big number. I'm going to check if this divisor is a prime or not. For that, I have to check if there's a divisor for this divisor. If there is any number that can divide this number with a 0 remainder. If it is, then it's not a prime. Then I will increase the count by 1. If count is 0, it means that there is no other number that can divide this number. It means that we found the greatest prime factor. Question 7 tells us write a code for a coin toss game. If player gets a tail, loses $2. But if player gets a head, earns nothing but keeps playing. If she gets consecutive 2 heads, that player earns $3. A player can play if she or he has enough money to play. So if a player has $1, for example, since the balance cannot drop to -1, we cannot play. If player has $2, at least the game is on. So we import random module because we are going to create a coin toss. You can also set this while amount is greater than 1 because otherwise player cannot play. We toss a coin, and to be able to get a random choice from the list, we use random.choice and we put the list here. This is going to give us a random letter from this list. So in this observation list, I am keeping our observations. For example, right now we got this observation is going to be added to our list. If the observation I got is a head and the second last observation is a tail, it means that I got my first head. So also the program is going to ask if we would like to continue or not. Or if my observation is head in this turn and my last observation is also head, I'm going to win $3. Rather than all these things, I'm losing $2. It means that the last observation, which is this one, was a tail, and it doesn't matter if I have a head or not. To be able to reach the second last number in my first turn, I created this one. I created this dummy observation with only T, because in my first turn I cannot get 2 heads. That's why I created a dummy term. If our answer is capital Y or small y, we are going to check if we have enough amount to play, printing an informal statement, and we are going to close the game, right? We're out of this while loop and we cannot play anymore. Let's say our amount is greater than 2. We can play, and this is gonna go to the the next iteration. If our answer is not Y, then it's going to print just goodbye. I want to make this game a little bit automatic. It always, this answer automatically is going to be yes, so we are not leaving the game. So now I would like to check how many turn in average I can play in this game with these conditions. So right now I'm going to play this game 1,000 times. So whenever I start a turn, I increase count by 1, and at the end of this playing part, I am adding this count. As an average, I play around approximately 9 turns. In the last question, I would like to see if we have an optimal stopping point. I want to be in the game until I lose my everything. So I would like to see if I stop playing when I earn enough. I would like to get out of the game. So I don't want to play anymore. I will just get my money and I leave. So I'm creating another loop here, which is called stop. And since my average was 9 in the previous question, I would like to play. I would like to set my strategy from stopping after 1 turn to stopping after 10 turns. So we will see the profit. So this is exactly the same code above. Only difference is now I'm adding the amount I made in this game. So whenever the turn I played is equal to my stopping criteria, then I'm going to leave the game. So this is for stopping criteria, and this is for, I'm again playing 1,000 games to be able to see the, in the big picture how this game looks like. Because if I play once, since everything depends on luck, I may not estimate in the long term if I'm going to earn with this game or not. That's why again I'm playing 1,000 times, or you can even play 10,000 times, 100,000 times. Don't forget to divide the sum by 100,000. If you update this number, you also have to update this number to find the average. This is the money I'm going to have on hand. As you can see, there is no profit, and this is not a profitable game because I started with $5, but now I have almost $3 on my hand